Okay, to completely factor this polynomial, we're going to use the rational root theorem. And Descartes' law of signs might help also. Okay, now what is the rational root theorem? Well, if f of x equals this function right here, the rational roots are c over d. Some textbooks use p over q. C or P has to be a factor of the constant term. And so there's all the possible numerators, all the factors, integer factors of negative 36. And the denominator has to be a factor of the leading coefficient, which is plus or minus 1. So these are all the possible rational zeros for this function. And one of the first ones you should check out is the number 1. You can actually do that without synthetic division. Just quickly put 1 in for x, and you'll see that they add up to 0. So 1 is a factor. If 1 is a factor, if 1 is a root, then x minus 1 is a factor. Now, how do you find the remaining polynomial? Well, one way to do that is synthetic division. So there's the coefficients of the original function, 1, 12, 35, negative 12, negative 36. 1 is a root, so we're going to synthetically divide by 1, and we do get a 0 remainder, which we expected. So that means these numbers are the coefficients of the quotient. So that means at this point, f of x equals x minus 1 times 1x cubed, 13x squared, plus 48x plus 36. Now, once we've got that one positive rule 0, the Descartes Rule of Signs says that the number of sign changes of f of x, the number of positive rule zeros, is that number, the number of sign changes, or is less than that integer by an even number. So how many sign changes are there in this function? Well, you've got plus, plus, then a minus. So there's one sign change. There's only one sign change. So that means this is the last positive root. Okay. And for f of negative x, the number of sign changes will be the number of negative zeros. So I can see 3 sign changes: positive to negative, negative to positive, positive to negative. So any additional roots that we check for will be negative. And one of the first ones to try is negative 1, because it's so easy. Well, I could almost see that negative 1 here and negative 1 here gives me negative 49. And these terms, 13x squared and 36, add up to 49 also. So I'm pretty sure negative 1 is going to give us a remainder of 0 using synthetic division, and there it is. Okay, so at that point, if 1 is a root, x minus 1 is a factor. If negative 1 is a root, x plus 1 is a factor. The remaining quotient polynomial or residual polynomial is x squared plus 12x plus 36. This guy is a perfect square trinomial. You can write it as x plus 6, the quantity squared. So there's the complete factorization. And the roots are 1, negative 1, and negative 6 with a multiplicity of 2. And that matches what we had here, 3 negative roots. There you go. Hope that helped. If you have any questions, post a comment.